2.6. All right. Marginals and differentials. Some more application to derivatives. All right. The word marginal in the business world basically means derivative. In the math world, okay? So we're going to talk about marginal cost, marginal revenue, marginal profit tonight, and basically we're just talking about the derivative of those things, okay? So, for instance, marginal cost. Bless you, I think.
Thank you.
Okay. All right, the marginal cost of something is the cost of producing one more item. Okay, the cost of producing one more item. So if I make 50 things, and I want to make 51, the cost that it takes me to make that next item is called the marginal cost. Is that okay? The same is true for I don't think I need to write, what would marginal revenue be then?
The cost of selling one more.
Well, not the cost, but the revenue of selling one more item, right? What would be marginal profit? The profit received from that one extra item. Is that okay? That's all it is. Those are the words. So it turns out that sometimes that's hard to do. How do you know how much it's going to cost you to make the 51st item until you actually make it? Everybody agree? Okay. I mean, you can estimate it, but do you agree from the last section that we just did? Isn't there a maximum somewhere? Right? And once you go past that maximum, now you're spending more money and not getting as much money back in return anymore, correct? All right. So therefore, what we'd like to do is it's hard to figure these things out. Marginal cost, marginal revenue, and marginal profit. So what we're going to do is we're going to estimate them. We're going to approximate them. Okay? And so the way we approximate them is we use calculus. All right. So what we're going to do, okay, is we're going to say that the cost of producing the next item. So everybody agree that C of x plus 1 just means the cost of, like if x was 50, this would be the cost of the 51st item then. Does that make sense? Okay. We're going to say that it's basically approximately equal to the cost of producing that item, take away the cost of the first 50, if the x happened to be 50, correct? The cost of the 51st would be the cost of that 51st item minus the cost of the first 50. That would be just representing the cost of the 51st item. Is that okay? All right. Well, in the world of calculus, the way we figure this out then is we do the following. We say that is, well, yes. We say that this is approximately equal to the cost of the first 50.
It's like saying 1 is approximately equal to 1 plus 1.
No.
No.
Alright, let me write it this way. Yeah, I don't like the way the book writes it either. What I'm trying to say is the cost of the 51st item, okay, would be the total cost of all 51 items minus the total cost of 50 items. And that would give me the cost of the 51st. Is that okay? That's basically, that's basically what this is supposed to be saying. Well, the way we're gonna do it in the calculus world is we're gonna say that the cost of making 51 items is gonna be approximately equal to the cost of 50 plus, plus the marginal cost, okay? The marginal cost of, not 51, but of 50, this is actually a 50, okay? We need, because we know how much it costs to make 50, correct? That's what we're making, so we know how much it costs. I wanna estimate how much does it cost to make 51 items. So what I'm gonna do is I'm gonna use my marginal cost of 50 and add that on to my cost of 50 that I already know, and that'll give me an approximation of the cost of 51 items. Does that make sense? A little bit? When we do an example, I think it'll become more clear, okay? So what I'm really looking at here is this line here. So, yes?
Just question, that second one you just boxed in, the C of x plus 1, is that, are you saying that that's the second C of x plus 1 in the first formula?
Let's not even worry about this. All right, I was copying down what the book had, but I don't like the way the book is written, okay? So let's do this. As an example, the cost of 51 items is approximately equal to the cost of 50 items plus the marginal cost of the 50th item. Okay? In other words, it doesn't make, I hope you understand that if we're trying to estimate this number, we can only use numbers that we already know to estimate something we don't know. Does that make sense? So we already know this one, and we can figure this out because it's based on what we know, right? And when we add those two together, that'll be an approximation for how much it's actually gonna cost us to do 51 items. Okay? So, let's try an example here, and let's see how easy you'll find this to be. Okay? Hopefully.
Producing one more item could cost real money overall.
True,
That
it's
would
not,
be the case if it's just one, and it's cheaper, but if it's a lot more than.
Did you guys get it discussed?
yeah, I was just saying, why couldn't we just take the total cost and divide it by 50 and get the cost per one item?
Well, because it doesn't work that way necessarily.
So you could put an 8-ounce can, like a 12-ounce filler, and have extra left over that you can't use. So you're wasting money.
Well, and also you have to take into consideration two other things, like my dad worked his whole life at a General Motors assembly plant. And, you know, you can only make so many cars a day, right? So if you wanna make that one extra car, you'd really like to make that one extra car, well, think of the cost that that could incur. Now you might have to pay your employees, you either have to add another shift, right? Cause in 8 hours, you can only make so many cars. So either you're gonna have to add another shift, or you're gonna have to pay them overtime, or something, you see what I mean? And you need to buy more supplies, and buying more supplies might get more expensive, because now you're buying it in larger supplies. You gotta run your power on your plant longer, that costs money. So all of that stuff gets, so it's not a linear, It's not a linear curve, we're making one is here, making two is here, and you can just predict, that's what we're gonna try to do to it. We're gonna try to make a prediction using a line like that, but in reality, it's a curve, and so, we don't actually know how it's gonna work. You see what I mean?
Yep.
There's a lot of extra costs involved in that, okay? I mean, and then you pay the employees a little bit extra money in overtime, but then you also have to consider that now that you're paying them overtime, now you have to pay your accountants, or you have to do something with them, because they gotta work longer to calculate the overtime and all that other kind of stuff as well, alright? Okay, so it exponentially gets bigger, okay? Now, if it was a linear situation, then yes, you would be perfectly right, you could just divide it by 50 and add one on, and that's the little trick that we're basically gonna do. Because we're just gonna approximate it.
Alright.
Alright, so,
Let's do it.
Alright, so, there's an example in your book on page 260, example number 1. And it says the following. It says, we have a cost function, c of x, that's equal to 62x squared plus 27,500. And they also tell us we have a revenue function, r of x, that is equal to x cubed minus 12x squared plus 40x plus 10. Okay, so we're given those two functions. Alright, now for part A, it says find the profit function. Alright, so there's not really a whole lot of math here. This is more of a business thing, right? What is profit? What did we figure out profit?
Revenue minus cost.
Revenue minus cost. So profit equals revenue minus cost. So all we're gonna do is write that down. So x cubed minus 12x squared plus 40x plus 10 minus 62x squared plus 27,500. Revenue minus cost. Alright, I don't like to leave stuff like that, so I'm going to clean it up a little bit. So x cubed, negative 12 and negative 62 is negative 74x squared plus 40x, and 10 minus 27,500 is negative what? 27,490? I'm just combining like terms.
Why are you subtracting?
Okay, so this one goes with this one, and this one goes with this one.
I just wrote it out next to each other.
That negative distribution.
Is it negative 62 originally?
No, it's a minus. So
It's
that's
revenue
minus.
minus cost, so you have to subtract the cost function.
I'll show you later what I'm talking about.
Okay. So that's part A, just write down the profit function, is that okay? Alright, part B. It says total cost, revenue, and profit from the production and sale of 50 units of the product. So they want to know now how much will all three of my functions be if I make 50 units. So they want to know what is the cost of 50, what is the revenue of 50, and what is the profit of 50. Now, how would you figure these out?
Plug it in.
You just plug 50 into each one of them. Does that, everybody understand that? So I'm not gonna waste your time with this, it's in the book. So C of 50 turns out to be 182,500. Where does that number come from? It's from taking the C function on the top there and simply plugging in a 50 for X. Okay? R of 50, we're gonna plug that in. And R of 50 turns out to be 97,010. And P of 50, we plug that in, and I get negative 85,490. So that's not a good sign when your total profit is negative. Okay. Everybody okay with those? Alright, part C. Part C then says, the marginal cost, revenue, and profit when 50 units are produced and sold. Okay, so now they want marginals. Okay, so marginals are the following. C prime of 50, R prime of 50, and P prime of 50. So they want us to plug 50 into the derivatives of these three functions. So before we can plug 50 in, we're gonna have to figure out what the derivatives are, correct? Okay? So, let's see what we can do here. So C prime of X, if I go back up to my cost function, is gonna be what?
124x.
124x, that's all there is to it. So that means C prime of 50 is just gonna be 124 times 50. And 124 times 50 is 6,200. Okay, so what did we just figure out? Any idea?
Marginal cost.
The cost of one more item.
That's the maximum cost. I don't know.
Okay,
So
what we
the cost
figured
of
out
producing
is
one more item.
this is how much money it's gonna cost, we're estimating it will cost to make my 51st item. We're estimating it'll cost $6,200 to make that 51st item. Is that okay? Alright, we can do the same thing for revenue. So R prime of X is gonna be a little bit more involved. 3x squared minus 24x plus 40. Okay, and R prime of 50 means I'm gonna plug 50 into all of those x's, and my book says I get $6,340. So the marginal revenue then is the amount of money I can estimate I will make on my 51st item. Is that okay? Now this is good, right? I'm making more money than it cost me to produce it, so my profit should be going up, but I have to make sure it goes up a lot, because right now I'm negative $85,000 in the hole, right? So I think I need to make a lot more than 50, but this is where we are. And my profit, P prime, is gonna equal 3x squared minus 148x plus 40. And when I plug in a 50 into that, I am told that I make $140. Okay? So I make $140 profit, obviously, on my 51st item. Now, to be honest, we didn't really have to do that to come up with 140, did we? How could I have come up with 140?
Supposed to subtract even.
Yeah, I mean, my revenue minus my marginal revenue minus my marginal cost should equal my marginal profit. But we're just showing you that it works either way.
That's a good way to check.
Yes, correct. How are we doing? So far, so good? Kind of get an understanding of what we're trying to accomplish here? We're using numbers that we already know, 50, to predict numbers that we don't know because we haven't made 51 things yet. Okay?
If something like this is on the test, you want us to show our work, or
Well, I would certainly expect you to show the derivative, right? Because that's kind of what class we're in. So I would expect to see this, how you
Okay.
get those numbers out of here. Okay? All right. That was a very basic example. So let's see if we